Now similar analysis we have to do for gender also. So we will put it as gender distribution, and we will use the same code. We will reuse our code. Simply I will change X as gender, gender distribution, gender and count, and let us see our plot. See, we have our plot here. Now from this we can derive an insight that male customers are more compared to the female customers, but overall it is balanced only. They are similar only, but male are on the slightly higher side. We need to, again we need to be aware of this also. So let us move forward. Now we will go ahead with bivariate analysis. That is, we will compare two variables simultaneously. So here we will analyze the relationship between different features and the target variable. Our target variable is exited. So, and we will try to identify some factors that will influence our customer churn. So let us see. Here we will be plotting the box plot, and the box plot will be plotted against all the features and the target feature. Let us see how we can do that. This we will be doing for continuous features, that is the numerical features. So see, just please notice how I am doing it. Figure comma AXARR means axis array. This is equal to plt dot subplots. I will plot a 3,2 array, and figure size I will give something convenient. Let us say 5,5. Now first SNS dot box plot. Here I have to give my x variable. X variable I will keep as exited in all my cases. Then I have to give my y variable. First I will begin with credit score. Just let me see what was my variable. Credit score. I have to specify which data it is using. So data is equals to df, and what is the position of it in the array. So axis is equals to AXARR. This will be in the position 0, 0. Now let us similarly, and this code can be reused. We will just copy paste this one, and we'll change the array position, that is plot position. I will just keep the list of my variables here. For that I simply have to do, for my convenience, df dot columns. Okay. So credit score is done. Next I will plot age. Next I will plot tenure. Let me just copy from here. Next I will plot balance. Next number of products and estimated salary. So number of products and estimated salary. Here I have to specify this position 0 0. This will be at 0 1. This will be at 1 0. This will be at 1 1. This will be at 2 0. And this will be at 2 1. Let us make it as tight layout. So plt dot tight underscore layout, and then finally plt dot show. So you see, here our box plots have been plotted. See, we could have done this separately also for each variable, but this was like compact and it was more professional, and we can get all the insights in a single look. So that is why we plotted it in a same plot. This one is not required, we can delete it. So see, there are few like observations generally that are made from these graphs. For now, let us see one or two observations. So we see that the customers who have exited the bank, they tend to be older compared to the customers who remained with the bank. So this suggests that age may have a strong relationship with customer churn. And then we also observe that there are many outliers are visible in the features such as age and balance. So we need to consider this when we are processing our model or when we are selecting our model. So let us move ahead. Our bivariate analysis is completed. Now we will do a correlation analysis. Here we will try to see how the variables, how the numerical features are related with each other. A very simple code, we have a very simple code for this. As usual, our first code will be plt.figure, and we have to define a plot. A figure has to be defined, that is done. And here we have to plot heat map. So we will do sns.heatmap, and in the heat map we have to plot df.correlation. And since we are only plotting for numerical values, we will just pass this parameter numeric underscore only equals to 2. Now to make it look a bit good, we will give annotation. I want it to be true, and I want the CMap to be cool warm. This you can check in the documentation. And I will give the title correlation heat map and plt.show. Let us see what we get. Okay, there seems to be some problem here. Let me put just one variable here. Let me see if that changes something. Empty equals to 0.2 f. Not much difference. I think increasing the size will make some difference. Okay, now this looks slightly better. I think we can increase the size even more. Okay, yes. So because of that size, it was getting congested. Now this heat map looks quite good. So from here we can we see that there is weak correlation between each other. The correlation is not very strong. So the multicollinearity is less. So this is generally good thing for our dataset, because if there is a this collinearity means that both the features are giving similar information. So generally we tend to drop one of them. So actually what happens, our collinearity with the target variable should be more and collinearity among the features should be less. That is the thing. So we are done with the correlation analysis. So our EDA for this project is completed as of now. There are many other things that can be done. You can always explore it, and it also depends upon the business situation and business problems. But for this project, our EDA is completed. In next section, we will be looking after feature engineering and feature encoding. So we'll see in the next video. Thank you. Thank you for watching.